Our topic today is the line of symmetry and the rotational symmetry. First of all, we are going to do the topic of line of symmetry. Remember one thing in this line of symmetry, that it is a line due to which the figure is divided into two equal parts, but they should map onto the other. So this is the basic definition of this line of symmetry there. So we are going to make it with the mathematical form that it is the line of the symmetry which is going to divide it into two equal parts. And the second part of this thing is, which are divided after two equal parts, they should map exactly onto each other. Now we take the example of this simple square. So this is the shape of that square. Which is A, B, C, D. So if you divide it through this diagonal, let's say we first make it on this board. Let's say this is the square A, B, C, D. Now, look, if it is folded about this line to the center vertically, then you see that A is going to map on D and B is going to map onto C. So there is one line of symmetry there. If you divide it into this way, then again it is another line of symmetry where B is going to map onto C and A is going to map onto D. If you fold it about this diagonal, then you see that they exactly map onto each other. So there is third line of symmetry. And if you fold it about the other line, then it is also mapping onto each other. So this is the fourth line, which is giving us the line of symmetries for that. So we see that there are four line of symmetry for this portion. Now we take an example of a rectangle. Let's say this is a rectangle ABCD. This is a rectangle A, B, C, and D. So if you fold it about this line through the center, then they are going to map exactly onto each other. So this means that there is one line of symmetry for this portion. If you fold it the other way, then you see that D and A, they are mapping, and B and C, they are mapping. So there is second line of symmetry there. But if you fold it to the diagonal, although it is divided it into two equal parts, but they are not mapping onto each other. This portion is overlapping this part. So this means that this third line of symmetry would not be there. The same is this case, that this fourth line of symmetry is also not there. So it is in the case of the rectangle, there are two lines of symmetries there. Now you can take an example of this parallelogram. If you fold it about the center, they are not mapping onto each other. If you fold the other line, they are again not mapping onto each other. If you fold it through this line, that is not mapping onto each other. And if you fold it about this line, that is also not mapping each other. So in the rectangle, you see that there is no line of symmetry for this part. They cannot map onto each other. So no line of symmetry in case of parallelogram there. But if you take consider the case of rhombus shape, which is like this, A, B, C, D, where all sides are equal, then you can have this example there. Let's say this is a rhombus there. So you can have through this line, then they are mapping exactly onto each other. If you fold it about this line, then it is mapping exactly onto each other. But if you map it like this, then they are not going to map exactly onto each other. So this line is not a line of symmetry, and this line is also not a line of symmetry. So there are two lines of symmetries in this case. So you have observed in all these cases that first they should be mapped into each other exactly, and the second one that is divided into two equal parts for that. For example, now there is a circle. It has infinite line of symmetries for that. So circle has infinite line of symmetries. If it is in the form of the words, for example, the word F is there, then it has no line of symmetry. If it is in the form of this word H, then it has one line of symmetry and it has another line of symmetry there. So there are two lines of symmetries for this word H there. So we have seen in all these parts that the line of symmetry means that it should divide it into two parts first, and then one part should exactly map onto the other part of the figure. So this is known as to be called the line of symmetries for the different shapes. You can observe it from this practical life. Now, the rotational symmetry. Rotational symmetry means first you have to find out the center of that rotation, and then the figure should map exactly onto each other. After moving it through certain angle, which is known as the angle of rotation. Now, we take the example of the first thing, that is for this square. Let's say This is the square we are going to find out for this, and this is the center of that square. So you call it like this, and it is basically A, it is B, it is C, and this one is D. Now this is the center. Now if you rotate it through this, so one time it is going to be rotated, so the figure will become, B will become at A, and this will be the B position, this will be the C position, and this will be the D position. After again rotating it through this, the base figure is the same. So A will come to this position, B will come to this position, C will come to this position, and D will come to this position. And again, if you rotate it, so A will become back to the original position. So after the fourth rotation, A will be at this position, B will be at this position, C will be at this position, and D will be at this position. So it means there are 4 rotations for this, and the formula there is angle of rotation is equal to 360 divided by order of rotation. So you have seen in all this case that after the 4 times rotation, the original figure is back onto this original shape there. So this is known as, we call the rotational symmetry. Now let's say we consider the second case. If it is a rectangle, let's say this is the center. If you rotate it through 90 degrees, then this shape will become like this. But they are not going to map onto this original shape. But if you rotate it through 180 degrees, then A will come to this position. This will be the position of B there. C and D. So this shape will be same thing. And then again, if you rotate it, it will be back to the original shape. So there are 2 order of rotations. So angle of rotation will be equal to 360 divided by 2, and that is equal to 180. If you move the third part, let's say we take the symbol of this parallelogram. Let's say this is the center. Then after 90 degrees, it is not mapping. After 180 degrees, it is not mapping. After 270 degrees, it is not mapping. But after 360 degrees, it is going to map onto this original shape. So there is 1 order of rotation there. So if there is 1 order of rotation, then the angle of rotation will be equal to 360 divided by 1, and that is equal to 360. So this is the way that you are finding the rotational symmetry, and the previous we are going to find out the line of symmetries for this portion there.